Hi, so hello and welcome to our latest video presentation about self-consolidating concrete or self-compacting concrete or the SCC. And of course, we have to do it using this template and referring to our guidebook, which is ACI 237R, and this one. Yeah. So in page 19, if you go to page 19, directly you can go through the procedure, which is the chapter 4.4 mixture proportioning procedure. Anyway, so going back to this template, so before we start, of course, again we have to update some basic values here, like the specific gravity of all these raw materials. You can find it from your third-party test report. Also the water absorption for the aggregates, the water content of admixture. You can ask your supplier or check from your test report or the technical data sheet. You can, and any admixture that you believe there is a water content, or by simply asking your supplier. So that is very important. Also, don't forget our dry rodded bulk density for all these aggregates. This is very important. Especially, it will provide us a good indication for the proper proportioning of these things. Okay, so basically, in summary, upon reading our guidebook, in summary, we have only these few requirements to follow as per the ACI 237R. So the volume of coarse aggregate, the paste fraction by volume, powder in kg, the typical water cement ratio, the mortal fraction, and these are the typical values. Now for the combined grading, this is actually coming from another guidebook which I have read. So I find it interesting and I find it useful also. But again, ACI has to prevail from this presentation because I believe that still, if we call for the specification standard which is internationally accepted, still ACI 237R is one from the top list that you have to refer to. So this combined grading is just a guidelines as mentioned by NRMCA SIP number 5. These are suggested combined grading bands only. It is non-mandatory guide and is not a specification, but it helps, to avoid your guesswork. So anyway, moving on forward, let's say in this example, we are required to provide a mixed design for self-consolidating concrete with a grade of C35 or 35 MPa cylinder compressive strength with the equivalent of 45 MPa cube strength. So let's write here 35 MPa for the cylinder strength, which is also around 5,000 psi, with the equivalent cube compressive strength of 45 MPa, which is around 6,500 psi. Next, our required nominal maximum size of aggregates. Say for example, it was 19 mm from the, let's say, specification in this example, and the required flow at site, because I believe this matters at site, not exactly from our plant. So this value came from, as suggested by the ACI, coming from table 2.5. So normally based on my experience that I encountered, so basically our contractor is looking for this requirement, the 550 to 650 flow at site, mainly because of, let's say for example, the element shape intricacy is high, so we need 550 to 650 flow. The surface finish importance is high, so again I need 550 to 650 mm flow. For the element is high, so again 550 to 650 flow. The wall thickness is low, so again 550 to 650 mm flow. And the element energy, or sorry, the placement energy is low, so again I have to use the 550 to 650 mm flow. So that is the reason why at site we are required a 550 to 650 mm flow in this example. And of course our target initial flow from the plant, I can say 700 mm in this example. So let's say our project specification calls for minimum cement content of 380 kg per cubic meter with a maximum water cement ratio of 0.4. And we can always begin from those requirements. So initially, let's say 300 kg, 380 kg of our total cement content and maximum water cement ratio of 0.4. So we can start from those values. Now don't forget also, since we don't have standard deviation in this example, now based on this calculation, I need to get a target mean strength of 53.3 megapascal at 28 days. That is QB strength. Or if you have a good standard deviation, let's say it was 3, so it will be reduce your target strength. So let's say we don't have any record, so let's keep it blank, and therefore I need to get 53.3 MPa at 28 days. That will be our target from the 45 MPa cube strength. So now let's say we found out that the water cement ratio to get this 53.3 MPa is, let's say I have to use 0.38. And as you can see, the lower value of water is 151. So to cover that, because there is a deficiency here, to cover that deficiency, I have to increase our total cement content, let's say 400. So I'm just starting to cover those basic requirements. Later on, we will see that I still need more cementitious content actually. So I have to explain again, the water content typically is 216 as recommended by ACI, ACI 211.1. But since I'm using the new generation admixture, the mid-range PCE based admixture, it suggests based on our experience or suggestion coming from the supplier, it can reduce 216, it can reduce like 30 to 40% of the target water. So in this example, the lower limit is 151 kg. So I just want to point out why the lower limit in this Excel sheet is 151 kg. Next, our volume of dry rotted coarse aggregate. So again, going to a recommendation of ACI, it's 0.62, and the lower limit is 0.56, upper limit is 0.68. But then of course, reference to the requirement of ACI 237R, we have to start with 0.5 as the volume of dry rotted coarse aggregate. Simply because this is a self-consolidating concrete, so we need less amount of coarse aggregate. So that is why you can say that this is now insignificant for us when we are working on self-consolidating concrete. Next, the air content is 2%. We will still have to use the 2% for the non-air entrant in this example. So finest modulus, upon combining these two fine aggregates, 50% natural sand and 50% crushed sand, we found out that the finest modulus is 2.8, so we are in the limit 2.4 to 3, the finest modulus requirement as per ACI 211.1. So I will not go through one by one about the calculation of dry rotted bulk density, mass of coarse aggregate, the solid volume of the fine, You can go back to our previous video for the beginner template and advanced template. I mean, just to save time, you can just check my previous video. So these are typical equation, and you will learn from my previous video also. So I will just assume that when you are watching this, you are already in the advanced template, or you are working on this SCC at the moment. So moving on forward, let's say I'm using 20% fly ash. So just enter the 20% here, and automatically we will get the 80 kg amount here. In this example, I use also retarder. By the way, this is coming from our actual trial mix, and the actual mix design that we supply also, we use 1 kg of retarder. That time I did not use VMA because this mix design was sufficient for us. Everything was comply. The test for the SCC, such as the J-ring, the L-box, the V-funnel, everything was passed, including the hardened concrete properties. So during those time, I did not use the VMA, but I suggest in your situation, maybe you need VMA or the viscosity modifying agent. Now, moving on to the combination of course aggregate. Again, of course, you have to go for the basic requirement first of ASTM C33, and in this example, it was complying for the lower limit and the upper limit upon combining the 19 mm and the 9.5 mm. This is the result of the combined grading, and these are the lower limit and the upper limit. As you can see that it is complying, or it is inside our lower limit and upper limit. And the same thing goes with the fine aggregates upon combining natural sand and crushed sand. So this is the result, combined grading, and this is the lower limit and the upper limit, again reference to ASTM C33. So these things are the basic requirements that you have to follow first before you proceed to a combined grading, if you have your own combined grading. And this is, I'm just suggesting you, it's a typical combined grading for SCC. So now for this part, we reach to the criteria as suggested by ACI 237R. So here the volume of course aggregate is met. We are 30% and the limit is 28 to 32%. For the paste fraction, 34 to 40%. So we are under the minimum requirement. We will fix it later. I'm just showing it to you. For the powder, it's okay. We are more than the 458 kg. Typical water cement ratio, we are in the limit as well. For the mortar fraction volume, the requirement is minimum 68% to 72%. So we are under the minimum requirement. So let me highlight you these two things that we have to comply or met. So basically, we need these two requirements to fit into, or the value to fit into the requirement. So to do that, I have to go back to our let's say the volume of dry rotted coarse aggregate first. Let's fix this one. I think I have to reduce it to 0.48. Let's see. So if 0.48 still not enough, so I need also to increase the cement content. So let's say 480, and now the paste fraction by volume is 37. So now we are okay with this limit. And for the mortar fraction, still we are under the minimum requirement. So one of the things that I can do now is to actually make this zero, the crush aggregate. No need to use this. And let's say 100% is the natural sand. So there are two things now that we will about to see or to find out. First of all, we fulfill the requirement of our ACI 237R. So we are inside the limit of this typical value. That will be great. So everything is okay, but now this typical combined grading is outside the limit. But if I go back to the previous proportion, which is the 50% and 50%, you can see that I'm fulfilling the requirement for this combined grading bands. But what I can suggest is that you do the trial mix for this combination. However, we are under the minimum mortar fraction volume, or one more trial mix that you can do is to use only 100% of the natural sand. Let's say in my case, in my example, because I believe you really have to follow this requirement of ACI 237R. So finally, we comply the requirement, and you can do this trial mix to find out. That is the next step to this mix design creation for the self-consolidating concrete. So reference to our standard again. So during the testing, so these are the typical test method that you have to use. The slam flow, reference to ASTMC 1611, the J-ring to measure our passing ability, the L-box for the passing ability also. We have here stability to find out the stability with regards to the bleeding and segregation. So upon doing all this test method, you can only say you fulfill the requirement of a typical self-consolidating concrete. So now you are more confident to propose your mix design. So another thing that I would like to share to you is the nominal maximum size of aggregates. So in this example, it's 19 mm, but reference to our standard again, if we are using such like 19 mm or 25 mm, so we have to use we have to follow the typical requirement for the volume of coarse aggregate to be 28 to 32%. But once we use 9.5, we can actually go as high as 50% according to the standard. And for the powder, we have to refer to this table. So these are the slam flow. So more than 650, you need 458 kg. So based on our example, we need 700 initial flow. So therefore, it is plus 458 kg minimum. So in case you want to start with let's say 600, so it will change to requirement to be 385 to 445. So I'm just showing you the functionality of this template. So let me just go back to 700. So that's it, and I hope you find value on this presentation. I hope it will help you, and if you feel it will be beneficial for you in long term, so you can check the link that I provided below. And again, thank you for watching. Bye bye.